Hi, in this video we're going to learn how to measure our workpiece. So for this lesson we're going to be using a milling machine, a Haas VF2 milling machine, and we're going to be using a program End Support Plate. So I select End Support Plate, we go into our simulator, and we have this simulation. Let's lock the camera to the workpiece. Take it off from single block and cycle start. You see it's a flip job, so we're starting from raw material, we're milling our shape, doing some drilling and some tapping and some reaming, I believe, and then we face it to its final size. Now we've run through our simulation, we don't have any collisions. The simulation appears to be correct, so we're going to, before we go to our CNC machine, we're going to want to measure and make sure that we're actually getting the right dimensions. So we select the measure icon, and that takes us into the measuring area of the simulation. Now think of the red and the blue and the green sections that you see here as sectioning the workpiece. If I swap my workpiece, there you go, now I can see my actual, as a solid model, my actual workpiece. And as I move these sections, you can see the section moving on the model. That's basically like if a ninja had a sword and they were slicing this workpiece for us to measure it internally, that would be the result. If I swap back, you can see as I move the different sections, what I'm actually measuring changes. So this allows me to be able to measure different areas of my workpiece, almost like slicing my workpiece or x-ray view of my workpiece. I'm going to slide the z-axis selection down so that I can see the pocket, and then we can look at how we measure some of the features of this workpiece. So in order to move those selections, I use the move section function. Once I select one of the other functions, it's off from this. So if I want to go back and move again, for instance, if I say measure an element, and I select an element and it's 2:21, and I measure those elements, and I want to go back and measure and move my sections again, I go back and I select move section, and I can select the section and move it again. If you'll notice the values, let me move out of the way again. If you notice the values change as I move those sections. If I want to key in a value, for instance, if I want to get a section right on a particular feature, and I want to see that section right in the middle of that feature, I can look at my drawing. I can at any time bring up my drawings by selecting the drawing button. And I see this hole is sitting at a location. We'll go this guy. This hole is sitting at 1 in 750 from my origin. These values are all from my origin, so it's 1 in 750 from my origin. And this one is 4.250, the center of this hole. So in my green selection, I'm going to say 4.250. In my blue selection, I'm going to say minus 1.750. Oh goodness, fat fingered it. Minus 1.750. And I've keyed in the exact center of that circle. So now I'm able to get measurement right at the center line of that circle. Or as I said, we can just click on them with my left button and move it to whatever area you need. Now we can only measure elements and points, which allows us to measure pretty much everything we need. But if I want to add more points, you see I just have points at what appear to be the start and end points of lines and arcs. If we have just this contour points selected, I get points wherever I start and end lines and arcs in my CNC program. It's a result of how I've programmed this part. So if I want to see points on line centers, I select line center, and now I have points at the midpoint of any of the lines. So if I wanted to, for instance, get a measurement to the center of this pocket, I could select line center, and that gives me right in the center of the line on either side of this pocket. Intersection points, if I wanted to measure, for instance, the overall size of this part, I could put lines at the intersections, and here where this and this line intersect, I've got an intersection point. Where this line and this line meet, intersection point. So I can calculate the end point of this sloped surface if needed be. If I need to measure the center of the holes, we can say circle center. And now I have points that I can measure to at the center of holes. Get rid of those. If I want to put points at any of the four quadrants of a circle, 0, 90, 180, or 270 degrees, I select that, and now I have circle quadrant points. And if I want to just put a point at the midpoint of any arc, for instance, these are just 90-degree arcs, so quadrant doesn't add any points. But when I selected midpoint of the arc, I gained a point right at the center of the arc. So let's look at measuring elements. If I select measure element, then I can click on any of the elements that I've created, and it gives me what we know about that element. This is a line who is 1.876 inches long. This is a circle who has a radius of 0.25, quarter of an inch circle. What if I want to see that as a diameter? The show diameter dimension icon turns my radius into diameter, so now I'm seeing circles as diameters. Arcs are not a diameter, arcs are only a radius, so whether I have the diameter selected or deselected, it shows me the same thing. This is a 312 5/16 radius. If at any time we want to zoom in, we can quickly zoom in by clicking the zoom rectangle. Left mouse click, hold it down. When I release, I zoom to the rectangle that I created by those two mouse clicks. Center scroll button rolls us back out. If I want multiple, if I want to see more than just one, I want to measure all these holes, I can select the measure multiple elements, and then instead of just one element, I see as many elements as I want to click on. So here, if I wanted to evaluate all of these holes simultaneously, and you can see all of the holes, all the information, X, Y, locations, radius, and so forth. If I want to see them as diameters, I can select diameter, but now I have multiple elements on screen, and they're numbered in the order that I clicked them. If I want to just work my way around a part, I can go select element, select an element. Now my arrow keys work clockwise or counterclockwise around the part. If I don't want to just measure elements, but I want to get locations, point measurement, and that sort of thing, I can use these next few icons. The first one is a coordinate measurement. So when I select coordinate measurement, my workpiece origin, G54, 5, 6, whatever it is, becomes the start of measure. And then whatever I click on, for instance, if I want to know the center locations of the circles, I can click circle center, click it, and it tells me what it knows about it relative to the origin. 1.75 inches from the origin in the x-axis, 4.25 in the y, a straight line measure of 4.596 and an angle of 67.620. So all of the math that we know about the location of that point relative to the origin. And we can do that for any of the points that we have. The next one is a relation measure. So if I don't want to use my workpiece origin, if there's some other point that I want as an origin, maybe instead of that side, the right-hand side, maybe I want the left-hand side, I could say, show me the intersection points. Make sure I've highlighted relation measure. The first mouse click is going to be this point. Now every subsequent mouse click is relative to that point. Very similar to coordinate measurement, but rather than my workpiece origin, I select the origin that I want. If I want to select another origin, I deselect. And then the next mouse click becomes my origin again. The next one is a chain measurement. My first selection is my anchor point. We'll say this end point. My next selection gives me my point. I get all the information. That second selection becomes the anchor point of my next measurement. So here, if I go to this point and then this next point, so the next mouse click continues the chain, so to speak. And the most simple one is a point-to-point measure. In point-to-point measure, I just select 2 points. If I select this point and then I select this point, I get everything I know about the relationship of one point to the next. Same thing, I select this point and I select this point. So click 2 points and we get a measure between those 2 points. If I want to know the depth of this rectangular pocket, I can select the top of the pocket, and the bottom of the pocket, 0.125 or 1/8 of an inch. I look at my drawing. Let's go just a little bigger. My pocket's supposed to be 0.125, so my depth looks good. So let's measure a couple of elements of this part that we've created and see how we did. We're going to go to a coordinate measurement, and let's look at the location of these 4 half 13 holes. From my origin, I'm 1.750 and 1.750. So I select this first hole and it's 1.750 and 1.750. That one's good. The next one, 4.250 and 1.750. 4.250, and that's good. Now these guys are 2.5 from one hole to the next, so we could go point to point and measure from one hole to the next. 2.5 inches, so we're good there. And let's check the 4.250 for this one. So we're going to say from the coordinate origin to the center of that hole, y is 4.250. So those hole locations look like they're in good shape. We're supposed to be 45 degrees on this taper. So we could do a point-to-point measure. We could zoom into this taper a little bit better. And then we can say from this point to this point is 45.001 degrees. We missed it by 0.001. Hopefully that's in tolerance. Hope's a good plan, right? Same thing on the other side. From this point to this point, 45 degrees. Very good. So there's not much information we can't gather from this simulation by measuring it. Now if we want to see our information in a different unit of measure, inch or metric, we go to our options page. In an environment, the unit system dictates what unit of measure. So if I say diameter of this hole is 0.5 inches, a half an inch. If I want to see that as a metric value, select the drop down, select metric, and now we're 12.7 millimeters, 39.898 millimeters circumference of that circle. So we select our unit of measure in our options page. Remember, red X when we're done to close. Restore defaults restores it to the default settings from when you installed. Now remember, in this simulation we had 2 pieces. We had an operation 1 and an operation 2. If we wanted to measure something from operation 2, I would select measure. I would click select workpiece. It opens a window and gives me the option of being able to select one of the 2 workpieces in my simulation. I'm going to select the workpiece 1. You can see it's highlighted in the vise. Okay. And now I have that workpiece. As I move my section, you can see on operation 1 we didn't mill all the way to the bottom. We have this squared area, and I could maybe measure the size of my workpiece when I started. 6 and 125 by 5.125. If I wanted to go back and select operation number 2 or my finished workpiece, I could select it. Okay, and I'm back to that finished workpiece. Now this is a result of my simulation. So we finished the simulation, we've got a completed workpiece, and we were able to measure the completed workpiece, and that's all very good. But if we wanted to measure before the workpiece was finished, we can do that as well. If we go to our automatic mode, we turn our clock down slightly, reset, and cycle start. If we wanted to get some rough information, we'll let this guy do some of its roughing. And I'm going to feed hold, so we've got an unfinished workpiece here, workpiece number 1. I'm going to go to measure. I'm going to go into measure, select workpiece, make sure I'm looking at my workpiece number 1. And now as I move my sections, I'm just measuring what I've cut to date, what I've cut so far. Now if I wanted to take any measurements at that point, I could take my measurements from that point and get that information. I can go right back into my automatic mode, click cycle start, and continue cutting that workpiece. I'm going to measure at this point. And you see we just have the spot drilling. If we wanted to section Z at 0, we could then, you see I keyed in a 0 for my Z-axis selection. We could go to measure the diameter of our spot. Make sure our spot drilling is of the correct diameter. 320 thousandths diameter spot drill. And back to automatic mode. So the measure function is a very powerful function. Don't forget, when you do your simulations, before you go off to your CNC machine with a good program and tooling list, make sure you stop and measure, and that you have no errors in your code. Even though it looks good, it may not measure good. So this is a great way to help ensure that you'll get a good result from your actual part before you actually cut and waste material on the shop floor in time. Thank you very much. I hope this was helpful, and we'll see you in another video.